Okay, I will try to make a universal way to solve limit problems. So you say if a is a finite number, if you want to calculate the limit of fx or limit of xx over gx, from the knowledge we learned from Taylor series, we know that any infinitely differentiable function, we can write it in terms of a polynomial. And that is a very powerful tool. We could potentially write this in terms of a derivative. And since we're doing the limit of x to the a, so might as well do the derivative at point A. So if we got that, then if we only have if we actually have a n equals to 0 term being written as it has a finite number, then that is your limit. If there's no there's a start at 1, then the limit is 0. Because we know that a limit x go to a, then this goes to 0. It's goes to 0. Goes to 0, very small number. So those are two scenarios. How about this? We could also do the similar thing, but top over bottom. And it can be into 3 scenarios. So the one is the same order. Sorry. So the limit of this obviously will be AK over BK, which is this. The other two scenarios, as you can imagine, will be one being there's one more order, and the denominator has an order after that. So as you can see, this is a much smaller quantity than the numerator. Then that will leave us infinity, because it's finite over finite over 0. And the other one, as you can think of the same way, is like should rearrange it in a different manner. Sorry. So this will give us infinity. And another scenario will be this is another order. This is a small quantity over a bigger quantity. And the limit of that is 0. So now you see that A has to be a finite number. We could transform this question to even an infinite scenario. So for instance, x go to infinity, function of x is equal to u go to 0. You can just basically transform that question to this question, and then this will back to this question, and same to if this not go to A but go to infinity. So as you can see, these three scenarios almost exhaust all the scenarios you may encounter. It's a very cheesy way to do it, I admit, but it works almost all the time. So you can keep try to look at it. So A naught 0, AK over BK, infinity 0. You can always check back to the video and pause it whenever. And let me give you an example. And I'm pretty sure you have at some point of your calculus encountered this type of question, or that exact question. So asking the limit of cosine x minus 1 over x squared. How to do that? So for at the beginning, like you just been told that we could have written cosine theta in terms of this. And you get negative a half. That's a final, sorry, that's the final answer. God, I hate that sound, I'm sorry. So the reason being, cosine x, the Taylor expansion is this. You just take the first two orders, because that's basically the scenario of AK, BK. And you got the answer is for this circumstance. And you could apply this type of things to all of limits. And this is one of the universal ways that I can think of to solve this type of question. Even though it's kind of reverse, because you have the limit is the knowledge, the foundation of derivative and the Taylor theory. But you could still use this type of knowledge to solve some questions, because sometimes you've been told of this type of things. How about like you told this is equals x equals tangent x. Spoilers alert, it is actually Taylor theory. And also this is also Taylor theory. And that, surprise, is also a Taylor theory. Oh, sorry. So yeah, you could use those type of things to solve limit problems, and it solved a lot of using the previous chalkboard notes. You can solve a lot of things with it.